Welcome to FeelElectronics. Have you wondered, looking at this in circuit boards or in electrical devices, and wondered what is this? What does it actually do? So it's basically this is a resistor, and this little part it what keeps the circuit safe, device working, and electricity in control. So today we are going to explore how resistor behave in series and parallel using simple ideas, clear examples, and a real breadboard setup. Firstly, what is a resistor? Let us take this example. Consider this as a pipe, and in this, water is flowing. Now, suppose the pipe is somehow bent, narrow, further, like this is the pipe section is narrowed from here. So, the amount of water flowing through becomes less. Hence, the resistor acts in the same way as a narrow section of the pipe. The higher the resistance, the less current will pass through it, or narrow the pipe section, the less water will flow through it. So from this you can get a basic idea of resistor. Now let's come to series and parallel. In series resistors, that is, the resistors are connected from one end of one after the another, like a beads or a string. So if the current is passing, let's suppose the current is passing, it passes from one resistor and after another resistor one at a time. It doesn't pass simultaneously in series resistors from A point to B point. But in parallel resistor, the resistors are connected in parallel. As you can see, the current which was supposedly flowing one at a time gets divided into I1 and I dash, and again after a certain connection it again combines into one. So the main difference is current passes one at a time in series resistance, and currents get divided in parallel resistance. You have to keep this in mind because in further the relation between the series and parallel resistance, current in series and resistance and current in parallel resistance, and voltage drop across series resistance and parallel resistance comes into consideration. Also, in series resistance, let's suppose this is R1 and R2. So if you want to find equivalent resistance, it will be R1 plus R2. As I've mentioned, this current flows one at a time. So the summation of equivalent resistance will be R1 and R2. But in parallel resistance, this differs. Usually it is R1 by R1 plus 1 by R2 if we consider R1 and R2 here. So from this, you can see that the resistance in series or the equivalent resistance in series, the value of this resistance is usually high. But the value of this when connected in parallel is usually low. This factor is very important. Okay, in series it's the equivalent resistance is high, and in parallel its equivalent resistance is low, because in series it's get directly added, but in parallel it's get inversely added. So when you want a circuit or when you need a circuit in which you want high resistance, then you can use series connection. And in case if you want low resistance in a circuit, then you can use parallel connection. This application you have to find out as you have to take all this consideration when building a circuit. So now let's take an example in breadboard, which is in series connection. As you can see, the breadboard, this is usually sorted in in vertical line, and this is usually sorted in horizontal line. I have just used this section to get a clear view. So as you can see, these are all connected in series. As you can see here, since it is sorted vertically, I have connected one end of the resistor to another end. This is usually the case. Yeah, you can connect in breadboard. There are actually multiple connections you can make in series. People usually find it very difficult when connected in series, or they may not know that is it actually connected in series or no. So let me take you some examples of series connection, like 3 to 4 examples how you can connect in series. Like, are you able to identify is it connected in series or parallel? So let's take the example second. See, as you can see, it may not look like series, but it is actually in series. See, here, since it is sorted, I would suggest you to follow one rule. How you can identify whether it is connected in series or parallel. If only one end of the resistor is sorted and the others are open, you can consider them as series. See, as you can see, only one end is sorted and other end of this resistor and other end of this resistor, they don't have any connections. In case of parallel, it becomes inverse as both the ends are sorted equally. In series, only one end is sorted. So this is example number 2. So this is another example. Can you just comment, is it connected in series or parallel? I will show you the section view. So if you are thinking of parallel, then it is wrong. It's connected in series. As you can see, this is sorted. As I've told you, in series, one end is sorted, but this section, as you can see, they don't have any connection. This is one complete sorted and this is another complete in breadboard. See, they don't have any interconnected, so this comes under series connection. Okay, so let's move on to parallel connection. Yeah, as you can see, this is a example of parallel connection. One end and another end, both the ends are sorted, so you can consider this as a parallel connection in breadboard. So let's move on to second example. So comment down below, is it connected in series or parallel? If you are thinking of series, then it is wrong. It is connected in parallel. As you can see, this section is sorted and this section is also sorted. So as you can see, as I've mentioned, in parallel connection, both the ends, if they are sorted, then it is considered as parallel connection. So don't uh, get confused between series and parallel connection. Okay, you have to check, you have to follow my simple rule. If only one end is sorted, then it is in series connection. If both the ends are sorted, then it is in parallel connection. Okay, so yeah. And one more thing, usually in resistance, many of the people neglect the power factor. Like, consider this simple circuit. So let us consider this as load. This is R and this is some 5 volt or some. So now if you want to select a resistor, you will select it accordingly to the current limiting, or the how much current you want to supply to the load. But one thing should be also noted, that since resistor works like it absorbs the, it drops the voltage drop across it, and since it drops the voltage drop, it gets heated up. So when it gets heated up, it usually gets dissipates the power into heat. So like in some circuits, you have seen that even if you have connected the series resistor, sometimes the resistor gets burned. Okay, this happens due to the mismatched power rating of the resistor. Like in some cases, this may be of different power rating, and another one may be of different power rating. Usually power rating depends upon the size of the resistor. Like if suppose the resistor is this much big, then its power rating will be high. This resistor might be, for let's suppose an example, okay, this may be 10 watt, some power rating may be 100 watt. So power rating usually depends on the load you have connected. So one factor you have to take consideration, that you have to give appropriate power rating. uh, uh, when giving the color code, you have to also consider the power rating. So many of the people neglect it, and sometime in the circuit boards, they get their resistor burned during the long run. So yeah, this was all about the resistor. Thanks for watching.